Hello everyone, I am Pratishtha Nandani. Today I am here to explain the Scilab and some comparison of programs. My PBL topic is comparison of DFS and BFS and Bellman 4 and Ford Fulkerson. So first of all, what is Scilab? So main feature of Scilab is it's a free software. You can go through http www.scilab.org. From that you can download the Scilab. It's free, and Scilab can be run on Unix, Linux, Windows, whatever you have. How to install? You directly go to that website that I told in that, and then directly install and run that setup. Scilab is a free and open source software for numerical computation, providing a powerful computing environment for engineering and scientific application. Scilab is released as open source under the CL/CIL license and is available for download free of charge. Scilab, why we use Scilab? Because it's solve hundred of mathematical functions, and it high level programming language allowing to advanced data structure, 2D and 3D graphical functions. Here some functionalities of Scilab is there, like maths and simulations, 2D and 3D visualization, optimization, statics, control system design and analysis, signal processing, application development, etc. So today my topic is Bellman 4 and other algorithms that I told you. So what is the Bellman 4 algorithm? It's an algorithm that computes shortest paths from a single source vertex to all the other vertices in weighted graph. It is slower than Dijkstra algorithm for the same problem but more versatile, as it is capable of handling graphs in which some of the edges weights are negative numbers. So you can see here here is an example of Bellman 4. Now the BFS is an algorithm for traversing of searching tree or graph data structures. It starts at the tree root, arbitrary node of the graph. Sometimes it referred to as search key, and explore the neighbor nodes first before moving to the next level neighbors. Here you can see the example of BFS. It's a tree, and it's went for it go to search some particular routes. Now the DFS, it's an algorithm that traversing searching tree or graph data structure. Once it start at the root and explore as far as possible along each branch before backtracking. So here you can see the example. And now Ford Fulkerson method, or you can say an algorithm. It's an algorithm that computes the maximum flow in a flow network. It is called a method instead of an algorithm, as the approach to finding argumentic path in a residual graph is not fully specified, or it is specified in a several implementation with different running time. So you can see here is an example of Ford Fulkerson. So some comparison between DFS and BFS. So BFS stand for breadth first search and DFS stand for depth first search. BFS start traversing from the root node and then explore the search in the level by level manner, that is as close as possible from the root node. And DFS travels from the root node and explore till the depth is possible. As far as it's possible, it goes down. BFS can be done with the help of queue like FIFO implementations, and DFS can be done by a SEC like LIFO implementation. BFS is work on a single stage, and DFS is work on two stages. BFS is slower than DFS, and BFS require more memory compared to DFS. So that is the theory of that my PBL. Now the practical working for in Scilab. So just open the Scilab. As I told you, download from directly from the website and open that. here is toolboxes. So for working for some particular algorithms, you have to download some toolboxes like Navel or NTG, whatever you want. Now the toolboxes, I am installing that. So here I go to the Scilab help. In Scilab, it's automatically given some particular programs and algorithms that you can implement, or you can modify them for next purposes. So I'll click for the help browser, and now here is, you can see there is a Navel. Okay, so in Navel, just go to the routing algorithms, because whatever I am running, it's on routing algorithms. So I'll go to the routing algorithms. See, it's there is so many of algorithms that you can modify or implement, and here is my algorithm. So I am working on BFS. So here is the BFS. It's also showing what is BFS and all. I already explained that things. So I am directly going to the code. Like, see, here is an example. It's showing that initial network size, it's showing n equals to 150, and network square area is, it's showing that 1000. It's an example, so I'll start with, and its radius is 100. Now it's generating of a topology in respect with the local methods. Now the selection of source node from that function, and then application of BFS. So I directly run from that. So you can see here it's showing the output of that program, or you are directly playing from you are directly executing from that. You can edit from here, and you can for running any program, you have to go to the file. See, it's showing that I'll open the new file, and it's an not saved right now. I can modify it according to my work, and then I can execute from here. So like that. So like that in help browser. Now the next algorithm for me, it's Bellman-Ford. So here you can see Bellman-Ford, and performance of algorithm source node is there. What is the argument, what's the sequence, and all the description is here. Now you can see the code is there. You can run that code. Like here it's showing the whole, whatever the vertices are there. The next age is the negative weight age of the Bellman-Ford is all shows are there. And see, here is the, so here you can see the example is given for Bellman-Ford, and you can edit from that. The next algorithm is DFS. You can see the DFS description, and here is the code for that DFS, and it's an algorithm, and it's an example for the DFS. Like as a BFS, also in DFS it's showing the network size, network square area, size, radius and all, but the functionality of BFS and DFS is different. Here is the DFS and BFS and Bellman-Ford, and here we see the whole algorithms and some examples for that. Now the next on next comparison of that BFS and DFS, I'll already shows that in this. So that's it. Thank you.